Hi everyone, and welcome to another one of our popular webinars that we've been producing here at Applied Math Modeling. This one is going to be a little bit different. We're not talking so much about airflow and cooling and thermal components today, but we're going to be talking more about workflow, and in particular the way that CFD fits into the DCIM overall solution. Now, before we get started, for those of you who are attending, there is a GoToMeeting chat or questions panel over on the right-hand side of your screen where the webinar recording is taking place. By the way, today's webinar will be recorded in case you want to look back at it. But instead of leaving the mics open, what we find is easiest to do is for you to actually type in a question in the questions panel. And I'll take the questions and we'll handle them as appropriate. I'll answer them audio, in terms of audio, answer them on the air. I'll do a write-up and reach out to you singularly if you'd like after the webinar to follow up on any questions that aren't handled in the webinar. So that's sort of our overhead. The recording will be posted on the CoolSim website, coolsimsoftware.com, later on after I produce it and put it up. And I'll try to include the questions at the end as well. So we're going to run for about 45 minutes here. Then Scott and I will be available to take questions. I'll open the mics up at that point. If I can, if you have a mic, we can certainly bring you in. Otherwise, type it in and we'll try to handle it the best we can. Thanks. So let me get started here just by doing some introductions. Most of you know me. My name is Paul Bemis. I am the president of Applied Math Modeling. We produce the CoolSim application. CoolSim is used for, of course, the analysis and operational characteristics and modeling of a data center environment. We are a partner of the Ansys Corporation. The solver for CoolSim is the Ansys Fluent CFD solver. So we have a license to that, and we provide that on a SaaS level basis, software as a service. So it's a different delivery model. It's very effective, and if you are interested in learning more about it, certainly let me know after the event and I can show it to you. And today I'm thrilled to have with me Scott Milken. Scott has been involved in the Open DCIM project for quite some time. And let me turn it over to you, Scott. You can do a quick introduction.
Okay, thanks, Paul. So I am currently the Computer Facilities Manager at Oak Ridge National Laboratory. And basically, it's just a fancy name for the interpreter between IT and facilities here at the laboratory for our data center projects. So I'm pretty much the person in charge of logistics and determining where the systems go and getting all of the different pieces that have to move in order to get that to happen. Before that, I was the data center manager at Vanderbilt University. Did that for about 5 years. And before that, I was a data center and telecom industry analyst at Sun Microsystems for around 4 to 5 years as well. And then I also had a stint with Blue Star Communications, which was a telco, a CLEC, that specializing in DSL. And before that, I'd been working in data centers with Dun & Bradstreet software division that became called IMS Health. So been working around data centers and communications for about 2 decades now. When I was at Vanderbilt, I started working on a project that ended up becoming Open DCIM. When I left there, I asked the university if it was okay if I converted it to open source, and they said yes, that is fine. So ever since I've moved over here to Oak Ridge National Labs, I've been developing it, and I've gotten other developers involved. And you'll see as we progress throughout the presentation here how it's evolved and grown.
Now, Scott, one of the things you mentioned that I find kind of interesting in your current role is that you sit between IT and facilities. You're kind of stuck in the middle there in a sense. And I see this DCIM topic, particularly because I'm on the CFD modeling side. I'm more on the facility side as a provider. But I see this sort of contention going on between IT and facilities, and you must see that in spades.
Absolutely, absolutely. So the problem is that this middle ground that the data center manager lives in, and I think a lot of data center managers are in that same position as me, they don't really have funding specifically for them. They are having to convince the two sides that they work with to actually provide funding to them.
Yeah, kind of an interesting evolution there, huh? So let me go ahead and hand this to you too. This next set are yours.
Okay. So as I was saying with the whole funding model, data center efficiency, it's not easy being green, and as many of us know, if you ask a data center manager what's green about a data center, the answer they would immediately give you would be nothing, nothing at all. But there are things that we can do to try to make things a little bit more efficient, or in some cases a lot more efficient. But typically your low-hanging fruit on that is your airflow management, blanking panels, your separation of hot and cold. So trying to figure out the most effective way to do that, it's kind of the puzzle that a lot of us are trying to solve here. Because efficiency it's really this big macroeconomic problem that the funding, the costs affect the facility operations. They usually have to pay the actual utility bill, but IT is who is putting these systems in that affects that airflow, and their decisions that they make have repercussions in other areas. If we go on to the next slide here. So let's also talk a little bit about downtime. So that's another area that I have to worry about as a data center manager, is trying to reduce that downtime. You want to charge it to whoever, if you have a service level agreement, you have to charge it to whoever is basically at fault. So human error, we hear this a lot, human error is the largest factor in downtime in data centers, but what does that really mean? Well, it could be an inconsistency in the environment. Customer A may do something one way and customer B does it a different way, and you could have 30 different customers and not a single thing that's common between all of them. Lack of documentation certainly is a major factor in that. Lack of training, and just an unfamiliarity with the implementation. So simply put, there's really no overall overarching process in a lot of places that says this is how we are going to operate, this is how we are going to do things. Now, maybe in some of your larger colo facilities where their money is made off of doing this kind of work, you would see more of those types of processes and separation of duties and how things are done. But in your typical enterprise type of data center, this is something that I've seen, both here and in previous jobs.
Now, one of the things I've heard you make a comment about before, Scott, is the difference between people who are in the data center business and people who just happen to have data centers. Can you just elaborate on that a bit?
Yeah, actually, so I've been bringing that up quite a bit. I'm also the president of the Tennessee chapter of AFCOM, which is the organization that puts on Data Center World. And one of the messages that I've been giving every time that we have a meeting, and that I've been kind of iterating back up to the national level, is that most people, when they think of a data center peer networking group, think of a group of people who work in the data center industry. But that's really not what the peer groups are for, and that's really not what DCIM is for. I think another problem with DCIM's message is that it's really just focused towards the colo facility or companies that make their money by being a data center. But that's not what the majority of data centers are. The majority of them are just a business that happens to have a room that they got to stick a bunch of computers in. They may be in the healthcare industry, they may be in manufacturing, they may be in finance. A lot of different industries out there, and they all pretty much have got the same kinds of problems.
Yeah, it's kind of interesting that this issue of no process often comes up as a result of the fact that you never really wanted the data center to begin with. You just sort of ended up with it, I suppose, right?
Right. It's typically, well, I'm really a system admin, or I'm really a network engineer, and I just got stuck with having to also take care of the data center. So, some of the things that we've done is we've been standardizing what makes sense. So computer science, which is what we really deal with here, and climate science and physics and chemistry, molecular biology, you name it. Well, it's about mathematics and data structures, but it's not about mechanical cooling. It's not about electrical distribution, capacity management, or energy efficiency. So asking the customers to make decisions based upon things that they really have no training on, and even beyond that, any interest in, it's not a very good business model to work with.
Right.
So you've got to have a data center manager to take the responsibility for those things the user has no expertise in. So you've got to find a way to fund it so the user doesn't try to value engineer every single system, but you kind of have to change the business model so that at least the data center manager has some mechanism or some teeth in being able to say, this is what you do. This is how you're going to track things.
Mm-hmm.
So as I was saying, I kind of live in that area in between IT and facilities. You know, I'm also integral into the purchasing process as well. So a lot of the tools that I've seen in the past were basically systems designed for one thing that they tried to make work for the data center. And unfortunately, I've never really seen one that really works well. So for instance, if you take a look at your typical asset management system, that's normally driven by finance. Finance is who wants to know what's the value of all of my assets that are still sitting in this building. And they really look at everything as more of a 2D problem. But in many cases, your description for an asset management system is simply driven off of what the PO said. So the purchase order may have said, well, you bought a switch, 2 servers, and some storage. But there's nothing that really tells you where in the data center you put it. As we all know, there are racks. It's a 3D problem. You could have hundreds of racks in a single room, so trying to track that down could be a nightmare. It doesn't track the physical characteristics. So the 2 servers that I have there, in the example, I've got one that's $16,000 and one that's $35,000. Is the $35,000 one twice as large as the $16,000 one? Does it use twice as much power? There's no way to really track the relationship between the devices either. So does the storage attach to the server? Does it attach to both servers? Does it go through the switch? So
right.
Kind of the problems that we run into with trying to shoehorn a system really written for one problem and try to cover something else.
Mm-hmm.
So some people try to use a network management system to handle their DCIM capabilities, but unfortunately that really only looks at the network and it focuses on monitoring. I mean, monitoring is very different from planning and capacity management. If something is not actually in place, you typically can't monitor it. And so looking at your future needs becomes a real problem. Also, a network management system is really, really good and really, really powerful at making an abstraction of complex logical connections. You can have virtual networks spanning all over your campus that ride on common lines. You can have, one line with 50 VLANs or 500 VLANs on it, for that matter.
Mm-hmm.
Lots of times it'll jump into network security. But the other issue is that your data center technician who is going to be out there turning a screwdriver and mounting systems into the rack may not know the complexities of all the network either. So it kind of gets beyond the typical capabilities of your where the rubber meets the road techs that are working in the data center.
Mm-hmm.
Then we can start taking a look at, like a building management system. So, large facilities are always going to have a building management system. This is driven by facilities. So a facility says, I need to be able to monitor my chilled water plants, my VAVs all over the place. I've got sensors all over the building. I've got valves that I need to monitor, et cetera. It's really good at working at that macro level. So it can tell you the big systems for multiple buildings, but if you want to start tracking individual pieces at the micro level or at the cabinet level or at the U level within a cabinet, not so good.
Again, not 3D, and furthermore, you begin to face the issue of how do you handle planning? What happens if? So far,
exactly.
The what happens if hasn't really been touched at all, right?
Yeah, and the other thing is I have yet to see a building management system that really lets the user make modifications to it. It's pretty much always going to require an integrator to come in every single time that you make even the smallest change. So
yeah, which
from
gets
a cost
expensive.
perspective, it really adds up, and from a time perspective, a delay. I don't want to have to put in a new system in the data center and then have to submit a change order to my system integrator and then wait 30 days for them to implement the change order and get the new monitoring up.
Right.
So OpenDCIM is a project, like I said, I started it at Vanderbilt. It's open source software. That means that there is no license fee in order to run it. It also means that if you like what you see in it but you want to expand it, you are welcome to take the source code, because that's how it's delivered, is in the source code, and make the modifications that you want. And we've actually got a lot of the user base is doing that, especially with the reporting capabilities and integration with their own systems in-house. I say it's maintained by me. Basically, I'm the architect that keeps the project within scope and keeping us from bouncing outside of scope of what we should do. But I'm not the number one person that's actually developing for it now. We've got a team of several developers around the world, as a matter of fact, that are contributing to the project. So I would say that I probably do 15 to 20% of the coding these days that's put in there.
Could you just spend a second on LAMP stack and define what that is for us, Scott?
Yeah, so LAMP is a common acronym. It means Linux, Apache, MySQL, and PHP. So Linux is the operating system. It's an open source version of Unix. It's very common. Mm-hmm. Apache is an open source web server. It's actually the most widely deployed in the world, according to Netcraft statistics. Mm-hmm. MySQL is something that was started as an open source database system. It has actually been purchased by Oracle since then, but they've allowed it to remain. It's kind of a hybrid of open source. They maintain ownership and copyright of it. It's kind of gotten muddied, but it's still considered an open source database stack that's out there. And then PHP is an open source language that you can write in, and it's really optimized for web applications, especially web with back-end databases. So
you tried to maintain as much neutrality as you could with respect to device dependence.
Absolutely, absolutely. So, and we say Linux, but we've got users who are running on Windows. There's a compatible stack called XAMPP, which runs on Windows. We've got people who are running it on Mac OS X. We've got pretty much, if it'll run a web server with PHP, for the most part, you can run it on there. Mm-hmm. But we focus really on three main areas that are kind of that gap in between what I was talking about earlier, the gap between asset or finance with asset management, facilities, networking, and IT. So we're looking at the physical assets, but we don't care about what they cost. So really it's where is it, how much space is it taking up?
Right.
Facility capacity. So not only do you model out what you have in your facility, but we also support measurement through things like SNMP managed power strips. So we can take real measurements of both power and temperature, humidity, et cetera, at however many points you want to in the data center. And then whatever that relationship is between the asset itself and the facility. So this is just an example of showing more physical detail. This is, typically how you would draw out a data center, a small data center. So we have an aggregate of the information, how many rack units are used, how much weight is allocated. That's an area that I think a lot of people overlook, especially the smaller data centers and the data center managers of those spaces, is even thinking, well, how much weight can I put in this rack before my floor collapses? How much power you allocated versus how much you've measured. So just trying to make sure that you don't have downtime because you overloaded a circuit.
Right.
And then how much cooling you've allocated.
Right.
At the cabinet level itself, we've gone 3D in giving you an elevation that's a pretty true elevation there. It extends the asset management concept from that 2D into 3D. It allows you to make reservations so you can plan for future projects. So that's really the big thing is, do I need to reserve this space for a project, and who am I reserving it for? Mm-hmm. And it also reduces error, because when you send a technician out, if they've got a tablet with them or some other mobile device, laptop, they can pull up DCIM and they can have a picture of what the cabinet should look like. Right. So if they get to the cabinet and it doesn't look like this, then they can say, wait a second, I'm in the wrong place. Or, I may have said, install DD2 and hook it into port 4 on the switch. They get there, say, well, port 4 is already occupied, so they can go ahead and fix the error because I had an undocumented connection into port 4 already, so they could add that and then change whatever the connection should be, use the next port, or whatever protocol you set up for, how you deal with conflicts when you enter your work orders and you're starting to actually perform them. We have a metrics dashboard for each cabinet. So I like to say, don't treat your cabinet like a checkbook. I've known many people who've really had that philosophy. Well, I have checks, I must still have money, and they kind of extend that into the data center. Well, I have space, I must have capacity. I don't know how many people that I've had to report up to, management-wise. That really felt like that. It's like, well, there's still space. What do you mean we don't have capacity? Why doesn't power equal space? So this lets you look at all the different factors that, or all the different legs of the triangle. Or really, it's almost more. Yeah, it is more of a triangle. So you've got your power, you've got your space, and your cooling. But basically, they'll allow you to look at all the different metrics and see how you're stacking up against your capacity. But one of the other things that I've added in, and I say here, efficiency is great to strive for, but don't forget about safety. That means you'll notice I've got the approximate center of gravity computed for the cabinet. So I've had so many arguments with system administrators who want to start putting in all of their systems starting at the very top of a cabinet. Well, if you've got them ganged together or you have tip guards, that's great. But as soon as they have 3 systems that start at the top and they pull out a 100-pound one, it can tip that thing over. So safety is one of the things that well, safety is really big in our culture here at the National Laboratories. So, and then I'm also a firm believer in using multiple models for power. So you should compute what you think it's going to use, but you should also measure what it is using now, and never depend on just one. Always look at the 2 and help make your decisions.
This is a big issue for us as well. We always obviously have to know the power being consumed by the computer in order for us to calculate the thermal gradient that it's going to incur. And of course, we have to do it without having any measurement because we haven't built it yet. So this issue of power is getting some focus, I noticed, by some of the organizations like Energy Star, who are beginning to push for better representations of power from the manufacturers based on configuration. Right.
We get so many systems in here where when you ask them, well, what is this actually going to pull under load, and they tell you, well, it's got a 750-watt power supply.
Right.
I'm like, well, that doesn't really answer my question. That just tells me what the capacity of the power supply is.
Well, that gives you the upper limit sometimes, right? They want to give you, and of course, I was in the computer business. I was with HP for many years, and we always built these things for max load, max conditions. So whenever we spec them for max condition because we didn't want to be limited. Of course, if we all do that, if every server does that, then you're over-speccing by at least a factor of 2 the power required to the data center.
Absolutely. Another philosophy that we have here, document every single thing that you touch. No detail is too small to bother with. If you take a look at the graphic there, you'll see in the operational log, I've got, replaced a bad DIMM in slot 3. This is your asset that you want to keep track of all of the different changes that you've made to over time. So, having a good way to keep track of that is important. So, we do that kind of stuff. If you make a physical connection between 2 things, it's important to document that. So we've actually got our power connections. So I know which power strip and which plug on that power strip and which power supply are involved in this whole relationship, so that we can tell if we have an outage on panel 1A-1, what's going to be affected. Am I going to have anything that's single corded that's going to go down completely, or am I just going to lose redundancy because I dropped one of the 2 power supplies there?
Now let me just jump in here and ask you about process, because the process to me seems to be the issue as much as software here associated with the whole DCIM issue. The process of having someone, and the someone being the right people, keep this database coherent, right?
Absolutely. You have got to make a commitment at the institutional level to not only get the data in, but to maintain it. And I've talked to other people who have had failed DCIM installations because they had support from a management level, and really it's in terms of money. They had support in order to get that DCIM installation put in, and they hired consultants to come in and do the initial entry of data, but they didn't commit to it after the fact to maintain it. And data centers are all about constant moves, add, changes, and deletes. Unless you are somebody like a cloud service or like a Google or an Amazon or a Microsoft, it is very unlikely that you are going to have everything that goes in with exactly the same configuration and never changes until it dies.
Right.
So what are some of the real-world benefits that, by implementing process, which then, as Paul and I were saying, that's really the number one thing. By implementing process and software as really just a tool to help us with the process, we have less unplanned downtime due to mistakes. We don't pull the wrong cable because we've got it documented. You put a label on a cable and all the heat and the air that's blowing over the cable, it'll cause the glue to dry up, and next thing you know, it's blown away in the wind. And so you go to do something, and you find cables that have no labels on them. Turning off the wrong system. If you again, you could have a label, something's either mislabeled or never had a label to begin with. At least you've got another way of documenting things that says, okay, this is where the system is that I'm looking for. Overloading a circuit. Hate to admit it, but it's happened here. We've had situations where, when the user was making the choices as to what they actually purchased, they were buying power strips with no metering on them. So they would ask me, do you have enough capacity to add this other server? And all I had to do was, or all I could do was look at them and say, I don't know. I can measure what you're using now, but I don't know if you're going to use the same amount in the day as you do at night. You could have, and the other systems that are in your cabinet, they could be cyclical in the way that their load is. Floor collapsing under load. I actually had that when I was at Vanderbilt. We had a really old data center that had a floor in it that was put in back in the 70s, and just over time, the wear and tear of what rolling these loads over a tile will do. It decreases the strength of that tile. As we went to 45 Utah racks and we really started loading those things in with lots of hard drives and got a really heavy load on it, we had a corner of a tile break, basically, and it tilted the cabinet, and we had to get riggers to come in and help move the thing off because we had exceeded what the load was for a tile that was put in back in the 70s. I mean, if you look at the progression over time as to what your loads would be, back then it was pretty common to, say, okay, I'm never going to go over 1,000 pounds. Find me a cabinet that's half full, it'll be over 1,000 pounds today.
Well, it's funny that most people think about density as thermal density. At least I do, but not so much mass density.
Well, yeah, and so having the safety culture has really helped, and that's kind of driven that portion of what we're doing within DCIM is also looking at the safety issues.
Right.
But it also gives you predictable growth costs because you can look at your historical information on your utilization. How quickly am I growing? But you can also have standardized infrastructure. Going to the next slide here.
Mm-hmm.
That's back to you, Paul.
So the way that predictive CFD modeling sort of ties in with DCIM is that it historically has not really been part of the whole DCIM thing. DCIM, I think more than anything, started off as a database, as Scott pointed out, of assets, kind of a two-dimensional kind of thing. And of course, CFD is three-dimensional. And it has historically been used by design build firms when they're laying out a data center to determine, if they have enough cooling and if the cooling can get to all the racks. The issue there, however, is that they don't know all the information at that point in time about what's going to be in the room. So they have to build it for a max load kind of configuration, which is often much higher than will be seen for a very long time. So the data centers are often running below capacity, certainly below their thermal capacity by quite a wide margin, which makes them tend to run quite inefficient. There are also, CFD historically has been quite hard to use and expensive. Tools like CoolSim have changed that quite a bit because it's easy to use and much more cost effective. We're building now application-specific tools for people who are doing data center design. This is in contrast to a tool like Fluent, which is a general-purpose CFD tool, quite capable, but knows nothing about data centers, and so you have to spend a tremendous amount of time in the setup procedures to get it actually set to model a data center. But what it's capable of doing, and it has been shown to be capable of doing over now the past 20, 30 years that CFD's been around, which is quite some time, is that it's able to accurately predict max load in a room, thermal load, so IT load in a given room, and also the optimal configuration for energy consumption. How do we minimize the energy consumption by the cooling system? Remember that for every kilowatt you put into the room for IT load, it's not uncommon that you actually consume another kilowatt in the cooling system, try to get that one out, trying to get that first kilowatt out. So I've given you there a ratio of 1 to 1. It shouldn't be that. It should be that it only takes about 0.25 kilowatts to get a single kilowatt of heat out of the room. I'm using kilowatt here in both terms of power and thermal load because it's the same unit, and it's easy to talk about it from that point of view as opposed to tons or BTUs. I'm using kilowatts for both. The ratio should be about 4. For every 0.25 kilowatts of mechanical energy, you should be able to displace a kilowatt of thermal load. That would give you a COP of 4 or roughly a PUE of 1.25, and that's generally how that works. But I often go into data centers and measure the amount of energy being consumed by the cooling system and find it equals or sometimes exceeds the amount of energy being consumed by the IT infrastructure, which turns your PUE and both your COP, your coefficient of performance, completely upside down. They're both wrong. And it's often because of configuration or poor airflow management or the fact that the site was designed for megawatt of capacity and is only running 100 kW of capacity. The other thing CFD is very useful for is disaster planning, failure mode and disaster planning. What happens if something fails? And that's an important thing to know before it occurs. These units have to be maintained. They have to go down for maintenance oftentimes, the cooling units. And what happens under those conditions is something that if people don't know what's going to happen under those conditions, they may be in for a surprise. They should know. It should be part of their overall planning process. So what's becoming evident, particularly for a lot of consumers of the kind of software we build, is the idea of combining or integrating the predictive modeling capability of CFD into a DCIM solution. What I'm being asked for is, let's not enter the data twice. Let's enter it just once. And with CFD now becoming easier and more cost-effective and becoming an occasional use tool and affordable at that level, then it becomes logical that you begin to use it when you want to do planning. And with tools like CoolSim, you can import data. So it was built specifically to be able to import data from an external source. We built it that way on purpose because we anticipated we would be downstream of a DCIM tool. Generally, people don't start at the operational level with CFD. They start with another tool like DCIM. The design build guys often use tools like a CoolSim, but then they leave. The data center gets handed over to the operational people, and they're using more of a 2D tool, as Scott talked about, such as a DCIM tool or some other thing, Excel spreadsheets, etc. And bringing these two things together gives you the ability to model cooling failure and equipment expansion and everything else. It gives you another planning tool in the overall management of the data center. So the way it works is the DCIM data contains information that is used by the CFD model, including location of the rack, power consumption of the rack, size of the rack, where the cooling units are sometimes, PDUs. And that data can be read into the CFD modeling tool. Now the data is filtered during import because there's an awful lot of data on the DCIM side that we're not particularly interested in on the CFD side. For example, it's not important where the switches are connected, for example, one to the other. The internet switches or the networking, the local area network switches, doesn't really matter about the mapping of those, cable labeling, things like that are not specifically important to CFD. What is important to CFD, however, is the thermal load, the airflow direction, if we can get it, where the equipment is in the 3D space. All of that information can come in and be loaded directly into the CFD model. So it's not so much about the room, it's about the IT equipment and the thermal load within the room. As well, if we can get it, what is the cooling unit in the room? What are the air temps from those cooling units? Oftentimes there's sensors and sensor data being fed into the DCIM system. We can use the sensor data to set the thermal boundary conditions for the CFD model. Now then what you can do is once it's in, you can go to CoolSim and you can just add the other incremental data necessary in order to do a simulation. So the workflow kind of goes like this. You have over here on the left OpenDCIM data. Now in Scott's case, OpenDCIM is an XML-based data structure, so isn't CoolSim, so that's very nice because the handling of that data is quite straightforward and quite easy. So we extract, he does an export of a certain amount of data out of the DCIM database, including rack locations, server descriptions, power consumption as best he has it for each of those servers, and that gets fed into the CoolSim model. Now in the CoolSim model you do have to add some incremental work. You have, for example, Scott's not going to have plenum height in his. He's not going to have, it's a drop ceiling, he's not going to have drop ceiling height. He's not going to have information about containment, for example, if he's got cold out containment. So there is some incremental work that has to be done to add the mechanical components that might be missing. Things like wall heat transfer function. I mean, is there an external wall that has a thermal load on it, pumping heat into the data center? Specific detail on crack data. What's the flow rate? What's the delta T? If there's any performance data on it. So there is a little bit of input that goes on over here. But then once the model's run, you can take the output and bring that back over and drop it into the OpenDCIM database, just like he's already bringing in monitoring data for thermal. So you could go to either position, but once this, and view the data, but once the model has been created over here, updating it and doing this loop can happen either on a trigger. Trigger is the idea that it's done based on a change that occurs on the DCIM system, and when a change occurs, there's automatically a simulation run, or can be done based on a date. For example, we do it monthly. And what you would have is a complete set of output data that represents the current state. And this is an asynchronous kind of loop. And what I mean by that is it's not continuously updating, so that you can take a snapshot, go to the CoolSim model, perform some what-if studies based on incremental load, and determine sometimes where the best position for the next expansion should take place in the data center. So we think this is a natural kind of representation that I see more people asking for. Certainly in my business on the operational side, I have people talking to me about doing this kind of work. Now we have a short clip here that I created. I thought it would be easier to show a video, and I'm hoping this will come through GoToMeeting fine. But this is a representation of Scott's database in OpenDCIM. And you see here we're looking now right at the data. It is XML data, and the XML data defines, for example, rack and row locations. So we're looking here at a row location. So it gives you the position in 2D space of where the rack is. And then, of course, within the data itself, it also shows you where the server is in the 3D dimension. So all we have to do is read in the data. So we just do an import of the DCIM data, and we grab the data set from a location and just read it. And what I'm going to be showing here is during the read, we actually left the graphics window open so you could watch the build. This isn't of particular importance other than you can see the servers coming in and building inside each one of those racks. So first it defines a rack row, it sets it back to 1 because he defined them one at a time, and then it goes into that rack and it just pours the data into the rack that defines the individual server. Now if he had also defined blanking and unblanking, that would be there as well. So the most important thing really coming out of the DCIM system for CFD is load, thermal load. Where is it? How much is it? And its location in 3 space. So that will go on, but that's how we fill the database. And the benefit of it is it allows you to do what-if scenarios. It's really the only way to do what-if scenarios. There is no other predictive tool outside of CFD that can be used for this kind of thing. I've seen sensors be used to create a current state, but sensors are historical in nature. They look at the past, or they look at now as well. So from this point right now into the past, they'll give you trending information, they'll give you historical information, but they can't predict what happens if you drop another 30 kW in the room, or where do you put the 30 kW in the room, or what happens if something fails. Sensors can't do that for you. Sensors are an important component for understanding what's going on now, and also can be used to set the boundary conditions for a CFD simulation, so that and to calibrate a CFD simulation so that you know the CFD is actually predicting what's going on now accurately. But then as you start to push into the future and say, well, what's possible to optimize this design, that's where CFD comes in. So we did, in this demonstration, open it up. I wanted to bring over a presentation or a representation of the model here. We have Scott's model right here in CoolSim, and I'm going to go to full screen here and show it to you. So this is a 3D model. His current representation inside of OpenDCIM is a 2D representation, which looks a little more like this. And you saw as the data is being read in, we're really getting information about the thermal components. These pieces like blocking and wall representations and the size of the underfloor were added by me. And in a brief discussion before we get started today, I asked him if this looked like his data center, and he said yes, except we have cold aisle containment over here. Again, cold aisle containment, not something that you would have in a DCIM system. It's something that you would incrementally add over here on this side. But this is a full 3D model now of his environment, and it can be calibrated now. Simulation can be run and output looked at to see if that matches what's there with sensors. And then you can go ahead and take the output from this, which I did submit a simulation here, and we'll see if the output comes back. But you can then just take this output, and it comes out in the form of HTML. So here I'm downloading from the server. The way CoolSim works, it uses a cloud-based server. So we did the compute on the server, and the output comes in the form of these So here I'm downloading to my computer, and I'm hoping it's not messing up GoToMeeting too much for you in terms of the audio or video transmission, because it sometimes does that. But here I'm downloading output. So here is my output. Again, you see my servers all defined in these racks. And we can now take a look at things like, did we meet the specification for the ASHRAE recommended thermal spec for inlets? It looks like, again, this is just an example. So I'm not sure this is completely representative of Scott's data center, but it's showing some of these servers are cold. They're too cold, in fact. They're below spec. And we also have one here that's a little out of spec. This is a PDU probably or something in his room.
Large tape library.
Yeah. So now we've got this full set of data. We can look at cut planes, and we can look at flow rate from tiles, and we can look at airflow underneath the floor. All of this data now available to him that wasn't there before. So he's got a representation of what's going on in the room. Now, of course, he's cold out contained, so we have to modify it. But easy enough to do, and you can export this entire set of data from CoolSim into an HTML report. So here I'm going to do an export onto my desktop of all the data that came out of this simulation. and here it is. So this is now, if you notice, it's looking at a folder on my desktop, and all of this data is now available to import into the DCIM system in any format that you want. It's being represented in HTML, but there's also 2D data here. There's also just text data here that defines the room, defines the cooling, talks about the energy, talks about the capacity of the cooling system itself, etc. So for each run, it generates well in the range of 20-30 megabytes of output data. Don't need to use it all, don't need to store it all, but it is all there, and it's all viewable through an HTML representation, which is very consistent with the implementation you've done, Scott, because you're running on a server already, and it's PHP, and that would fit very nicely. So that's kind of a representation. I thought here would also take your experience, Scott, and just ask you what to look for when looking at DCIM providers.
Well, so one of the reasons why Paul and I have been working on this is that as I started evangelizing about Open DCIM, was basically saying, why is it that there are so many solutions that kind of hold the data captive? They don't really tell you how to get the data or what the database structure is or things like that. I think that there really should be a lot more interoperability between various systems. So that's why Applied Math and CoolSim worked out so well here with the Open DCIM. So that's one thing, is what else can your DCIM package talk to besides things that are from the same vendor? Can the tool expand to store other kinds of data? Is it something that you can easily put custom fields into and take that extra information? What kind of support model? So now open source is not for everyone. There is no guarantee with open source software. For someone who depends on the data that's in Open DCIM as part of their business model, I would say open source is probably not the best solution for you. Pretty much because, while support is really good, and I think we've had a very good effort put forth by all the developers to support any questions that come along. Again, there's no service level agreement with an open source package, but it's very widely used. Can the tool be user configured, or does it need supplier support for customization? One of the big appeals for using an open source model, or at least the Open DCIM one, is that you simply download the package and then you start using it. I mean, there's really not a whole lot of interaction that's required in order to get it up and running. So it's very simple to use and very simple to deploy.
With respect to the same question for CFD modeling supplier, the big issue and the big motive for me to start the CoolSim product, in fact, I started it while I was still at the Fluent Corporation and then bought it and took it private with the company Applied Math Modeling. And my motive was occasional use. In other words, when I was at Fluent, we were selling CFD primarily to aerospace and automotive, and that was fine because their duty cycle of use was high. And so they could justify the cost of the software because, and the software costing $20,000, $30,000 a copy, they could justify it because they used it every day, all day. The issue here is that's not the case. What we have are occasional users, people who want to occasionally understand the impact of what happens if I drop 30 kW in the room and where do I put it. So occasional use pricing structure came about. I built it on purpose into CoolSim and put it on the cloud so that I could measure utilization. And once you understand utilization, then you can price based on use. It's a utilization-based model, as opposed to here's a license for it, use it as much as you want, but you've got to pay a big ticket because I don't know how much you're going to use it, and I have to bet on the fact you're going to use it a lot. That's the other model. That's the model used primarily by everybody in the CFD business today. This one's different, and it's made specifically so people could use it. I always felt it would be a good tool, but ease of use was an issue, and also price was an issue. The other big thing is, can you import and export data from it? We built CoolSim to export and import XML data, or in the case of HTML output. So yeah, and you can do it without paying extra. I mean, one of the other issues as well with local licensing for CFD was that you could only see your own results if you had a current license. Not true with CoolSim. You'll always be able to see it because we export it into a folder, and it's got HTML documents and PNGs and AVIs, standard AVIs. And it does have a little 3D viewing model as well, but the view is free. It's either free from us and also free from Ansys. Finally, does it have the functionality to do what-if scenarios? CoolSim has a parametric variation feature where you can set up 5 or 6 scenarios at once, launch them all at once. They run all concurrently because we run on the cloud, so it's a cluster that we're running on. And so you can do multiple variations at the same time. You don't have to wait for one to finish before you look at another one. And then finally, learning curve. You know, we're at the point where we don't have time, most of us, to go for training, to go spend a week somewhere doing training. We really have to learn how to do it on the fly. So the tool has to be such that you can learn how to use it when you need to use it. And the learning curve has to be short, and it has to be relatively easy to climb, because you often have to remember how to use it. If you're an occasional user, you've got to climb that curve every time you go back to use it. So yeah, I mean, in summary, I guess that we think, you know, capacity planning and energy consumption should be able to be attacked using tools that are highly compatible. With the recent reductions in CFD cost models that suppliers like CoolSim are putting forward, it now becomes manageable, easy to use, easy to afford. Integrating technologies is easier now because of things like standard data formats and filters. And if you're interested in working with Scott and I on this topic, let us know. And we're eager to work with people who are interested in this kind of approach. Scott, final thoughts?
I think you summed it up well. So love to hear from people who are interested in OpenDCIM just as much as Paul would love to hear from people interested in CoolSim.
Now, we do have a couple of questions here, so if you do have questions about this, please type them in or put your hand up now, and I'll go ahead and try to get at them. The first one is from one of my friends, Wayne Beck, who asked a question about populating airflow. He said, are the racks being populated such that they're front to back, or is that being pulled from the DCIM data? Actually, you've got airflow indicator in the DCIM data, don't you, Scott? So
that's correct. So
yeah.
you can specify as you define your racks within OpenDCIM what the airflow direction is.
Mm-hmm. So here, whoops, where's my my CoolSim model? Here it is, and here's the input. These racks, just so you know, are not my data at all. This is Scott's data. All of this stuff is his. And I'm noticing, Scott, that the labeling on it might need a little work. Is that something you recognize? OSTI AF05?
Yeah, that's actually the name of the cabinet.
Yeah,
that's the cabinet designator. Yeah.
I did notice inside the rack we've got a generic server, so probably need to do a little work on labeling. You've probably got unique labels for those, or not?
Yes. Yes.
Yeah. So again, this is an example. We do have an import filter for it, but we're still working on it. We're not completely done yet. Another case coming in, can these tools work with hybrid liquid and air cooling IT systems? Yeah, yes. Liquid cooling is no different than air cooling. It's just generally you have a heat exchanger somewhere. Oftentimes the heat exchangers are on the back. So we work with models all the time that have a rear door heat exchanger kind of thing sitting on the back, and those are just another cooling unit. The only difference, I suppose, would be if you have cooling inside the rack itself around the equipment, which is unusual, or you have immersed racks. I've seen those before, immersed in oil. And in that case, it's still a heat load. It's still a thermal load, so you can model it as a thermal load with just less heat because some of it's being pulled out of the room by something else, and you wouldn't include it. This tool is primarily for air cooling. You know, it's an air-cooled kind of thing, and the way the rear door heat exchangers work is they're still air. They just happen to put the heat exchanger behind the rack, so that's still air cooling. It's just closely coupled, that's all. And another question, what are the file format requirements for DC product input to CoolSim? The format requirements are XML data. I mean, it's you did a filter, or did we do the filter? I can't quite remember, Scott. You handed us XML data, didn't you?
Right. You told me which elements that you were interested in, and we created an export that would give you just those elements so that you didn't have to filter through quite so much.
Yeah, yeah, and it was just XML data, and all we did on our side was read the data and map it to our conventions. That's all. It's really just a filter that maps one data set to another. So the import, I mean, CoolSim itself will import XML data. So there it is right there, import XML, and you simply go to the XML sheet and pull it. Now, we're going to interpret it in a certain way, so it's probably best to filter it. But if you're interested in knowing what that is, we can define it for you and show it to you. Furthermore, though, everything can be exported. For example, if I edit this room and I want to do an export, I simply hit the export button and it writes out an XML file. You see it right there, an XML file onto my desktop. So you don't really need us. It's already there, and we expose it because we want it to be exposed. So I'm just going to export the room to my desktop, and now if I go and show desktop, I'm going to see that room. There it is in XML, and I can open it with an editor. Of course, I opened it with Notepad, so it's not very interesting to look at, but I could also open it with something a little more appropriate for that kind of data structure, like IE, and there's the XML data right there. So, you know, it's fairly well defined. I mean, in CFD, there's a lot more stuff than you're going to really need, like access labels and, you know, is auto snap on or off, or whether the user preferences. There's a lot of stuff there that you don't need. And we have GUIDs. GUIDs, of course, this CoolSim is a hierarchical object-oriented structure that has children. So you have the children geometries here of the room. But that's everything that's in the room is defined right there. And you just export it, have a look at it, and you can work with it directly. So we tried to make that quite easy. Another question coming in, does OpenDCIM accommodate locations-based rack and temperature monitoring? I think the answer to that's yes, but I'll let you. Yep.
Yes, it is. So you define on your map where your cabinets are located, and then you can also define sensors within those cabinets, and they will display. Paul, can you show the 2D model that we had from OpenDCIM early in the simulation there?
Yep.
When he gets that pulled up, you'll see that there are some cabinets are green and some are red and some are yellow. So that is an aggregated view. You can look at either just the element of, say, temperature or humidity or power or weight or space, or you can get a compound that says, show me the worst case of any of those. And that's what this particular view is, because most of those cabinets that are red are completely full, or you know, I've got it defined so that when you're 90% full, you turn it red, and when you're 80% full, you turn it yellow. So that's what those different colors are. But we do have the ability to read any SNMP managed sensor, whether it be in your Liebert unit or some other AC unit, or whether you've got your sensor in an intelligent power strip or something that's standalone. As long as we can get to it SNMP, you can add it in.
So you can do temperatures, power, cooling. Yep.
Yes, we can pull actual load for electrical, and you can also get your temperature and humidity.
Yep. Okay, I think that covers the questions we had 4 or 5. If there are any others, go ahead and ask. If not, let me just go to the summary here again and put up our contact information. If there's more information you would like about how these systems work and how they might work on your behalf, send us a note. We're both pride ourselves on getting back to people quickly and try to be responsive and engaged, and would love to work with you if you're interested. Any final thoughts, Scott?
I see that we both made the same mistake here on the contact page. Your web address is obviously www.coolsimsoftware.com. OpenDCIMs is obviously www.opendcim.org.
Mm-hmm.
So we put our email addresses, but forgot to put our website up there.
Now, do you have any idea how many people are using OpenDCIM at this point, Scott? I know that it
has been translated into several different languages. It's currently in English, of course. It's also in French, Italian, German, Chinese, Russian, and Slovenian. 2 different dialects of Spanish. We've got Galician and we've got traditional Spanish. And I don't remember if I mentioned Italian, but Italian is also one of the languages that it's in.
Wow.
So all those translations were done by people other than me because I don't speak anything except bad English. And actually we've had people request proper English because we've got several people in the UK that are using it. A lot of people have contacted me and said we can't give you the permission to publicly list us, but on the website we do have about 10 or 12 that have said that yes you can, and some of those are pretty high profile. But based upon the interaction that we get from the discussion mailing list, which is where people will ask questions of how do I do this, or is this a bug, or is this a feature that we can add, or things like that, I would say that we are well over 200 installed sites.
Mm-hmm. You know, it reminds me of an old joke, the language issue when I used to live in Europe, and the running joke there was that if you speak 3 languages, you're trilingual. If you speak 2 languages, you're bilingual. If you speak 1 language, you're American.
Pretty much.
Well, all right, Scott. Well, thank you very much for participating today. I found it informative and have gotten some good feedback from folks about it already, and look forward to working with you.
All right. Thanks for inviting me.
Thanks.
All right. Bye-bye.